Hello everyone, welcome you all to this video lecture. This is Selva Brinda, Assistant Professor, Department of Artificial Intelligence and Data Science from Ramco Institute of Technology, Rajbari. Today we are going to see about some of the basic concepts of stream processing. So before getting to know what is stream processing, let us see something about data processing first. So what is data processing and why do we need data processing? So, data processing is the collection, manipulation, and organization of raw data to produce meaningful information out of it. It is a crucial step in various fields, starting from the business intelligence to scientific research. It allows us to extract the valuable insights from vast amount of data. So, these are some of the stages of the data processing. So, these stages are considered as the data processing cycle. It has six stages here. First is the data collection, next is the data preparation, next is the data input, then data processing, data interpretation, and finally data storage. So, data collection is the first step in the data processing cycle. Data collection means collection of a raw data. This raw data should be gathered from defined and accurate sources so that the subsequent findings are valid and usable one. So raw data could be a website cookies, it could be a user behaviors, monetary figures, etc. The second stage is the data preparation stage. So data preparation is the process of sorting and filtering the raw data to remove the unnecessary and inaccurate data. So here the raw data is checked for errors, duplications, missing data and transform those data into a suitable format for further analysis and processing. The third stage is the data input stage. So in this stage, the raw data is converted into a machine readable form and fed as input through any input sources namely keyboard and scanners. The fourth stage is the data processing stage. The raw data is subjected to various data processing methods using the machine learning and artificial intelligence algorithms to generate the desired output. So, fifth stage is the data output or data interpretation stage. Here, the data is finally transmitted and displayed to the end user in a readable format in the form of the graphs, tables, charts, audio, video, etc. And the last and the final stage is the data storage. Data storage allows for quick access and retrieval of information whenever needed. So next comes the types of data processing. So here we have five types of data processing. First one is the batch processing, next is the real-time processing, next is the online processing, then offline processing, and finally stream processing. So let us see one by one. So first is the batch processing. So batch processing is a method to handle large volumes of repetitive data efficiently. So here the data is collected and processed in batches. So batch processing groups the similar tasks together and execute them periodically as a single unit. So execution can be done either offline or during off-peak hours. So some of the examples of batch processing is payroll and credit card billing. So a good example of batch processing is the credit card billing that is done by the company. So when customers get their credit card bills, it is not a separate bill for each transaction. Instead, there is only one bill for the entire month. That bill is created using the batch processing. So all the information is collected during the month, but it is processed only on a particular date all at once. So that's all about batch processing. Next is the real time processing. Real time processing came into existence with the advent of the internet. So, real time processing often refers to the ability to analyze and process the data as such it arises. It aims for extremely low latency, ideally in milliseconds or even in microseconds. This enables the immediate insights and actions based on the data. So some of the examples of real-time processing includes fraud detection system and withdrawal of money from the ATM. So the difference between batch processing and real-time processing is depicted in this figure. So here, for batch processing, the information is extracted by the employee and they process those information in the system. Whereas in real-time processing, the information as such it comes is processed by the system without the requirement of the employee. So batch processing takes 20 minutes to process the information, whereas real-time processing takes less than 1 second to process the information. So next is the online processing. Online processing is also known as the online transaction processing. It refers to a class of systems that facilitate and manage transaction oriented application, typically involving data entry and retrieval. So, in simple terms, online processing is a method of processing the data where transactions are processed immediately without any delay. So, online data processing is often confused with the real time data processing because both receives and process the data simultaneously. But with online processing, the user can extract the data anytime, anywhere. So all the online systems are not real-time systems. So example for the online processing is the barcode system. Next is offline processing. So offline processing, it is a contrast to the online processing. So offline processing refers to operations that do not require immediate connection or interaction. It involves working with the data or performing calculations without relying on a real-time network connection. So some of the examples of offline processing includes downloading files, email composing, etc. So next is the stream processing. So stream processing is a data processing technique for dealing with the continuous flow of data in real time. So continuous stream of data could be generated from sensors, logs, social media feeds, financial transactions or IoT devices. The stream processing handles data in real time or near real time, allowing for immediate analysis, monitoring, and response. So, this diagram depicts the difference between batch processing and stream processing. So, in batch processing, large amount of data is split up into batches and each batch is processed and the results are extracted out of it. Whereas in stream processing, the real-time events as such it comes is processed continuously to get the live results. So next comes how does the stream processing works. So stream processing allows the application to respond to new data events at the moment they occur. So here the stream processing consists of three components. One is input data, next is stream processing engine, and finally outputs. So the input data pipeline is processed by the stream processing engine in real time. The output data is delivered to a streaming analytics application and it is added to the output stream. So the output can be in the form of the visualization. So some of the actions that stream processing performs on the data includes aggregations, analytics, transformation, enrichment and ingestion. So these are the five actions that is performed by the stream processing on the data. So first one is aggregations. Aggregations is nothing but it is a calculations. So calculations can be a sum, mean, standard deviation, etc. So analytics, it is nothing but predicting a future event based upon the patterns in the data. Then transformation, it is changing a number into the date format. So enrichment, So combining the data point with another data sources to create a more enriched context and meaning. And finally, ingestion. Ingestion is nothing but inserting the data into a database. So these are the five actions that is performed by the stream processing on the data. So why do we need stream processing? So there are seven reasons why do we need stream processing. So first reason is to develop adaptive and responsive application. Next is to help an enterprise improve real-time business analytics. The third is to facilitate faster decisions. Next, to accelerate decision making. Next, to improve the decision making with increased context. Then, to improve the user experience. And finally, to create the new applications that use a wide variety of data sources. So these are the seven reasons why do we need stream processing. So next is key characteristics of stream processing. So let us see some of the key characteristics. So we have five characteristics here. So first one is the real-time processing. So stream processing aims to analyze and react to data as close to real time as possible. So next characteristics is continuous. So stream processing have the capability to deal with a continuous stream of data. Third one is stream processing have the capability of low latency. So it processes the data with a minimum delay. Next is scalability. So stream processing systems are designed to handle large volume of data efficiently by scaling up and scaling down whenever needed. And last characteristics is the fault tolerance. So stream processing systems can recover from hardware or software failure without losing the significant data. So these are the five characteristics of the stream processing. Next is the stream processing architectures. So we have two stream processing architectures. One is Lambda architecture and another one is Kappa architecture. So this Kappa and Lambda architecture are two prominent stream processing architecture designed to handle continuous data streams. They both differ in their approaches to processing and data storage. So first let us see Lambda architecture. So Lambda architecture is a data processing approach designed to handle large volume of data efficiently. So it combines two processing layers. First one is the batch processing layer and next is the real-time processing layer. So the real-time processing layer can also be called as the speed layer. So batch processing, already we know it takes the data, large amount of data and process those data in the form of the batches. So it processes the data periodically, either daily or weekly or monthly or overnight. So the processing can be done periodically and this batch processing ensures high quality data but potentially experiencing higher latency. Whereas the real time processing or the speed layer focused on the recent data streams. It provides near real time insights with lower latency. So this layer may slightly have a less accurate data when compared to the batch layer. So this is the Lambda architecture. So it has three layers: batch layer, speed layer and serving layer. And data sources and query is included in the architecture. So let us see each component one by one. First is the data source. It indicates data can be obtained from the variety of sources. So from where we are collecting the data. So that indicates the data sources. Next is the batch layer. So this layer process all the data using batch jobs. So it typically scheduled to run periodically. That is, it can run daily, it can run weekly, or it can run monthly. So it could be scheduled to run periodically. So the tools used in batch layer is ETL tools, that is the extract, transform, load. So this tool is used to process the data, to clean the data, to transform the data and load the data into the data warehouse or any other data storage system. So this layer ensures data consistency and accuracy for historical analysis. The next stage is the speed layer. So it is also considered as a real-time processing. So this layer processes the data streams in real time with lower latency. It uses the technologies like Apache Kafka or Apache Spark streaming. So this layer provides near real-time insights but may have slightly less accurate data when compared to the batch layer. Third layer is the serving layer. This layer acts as the unified interface for querying and accessing the data. It combines the results from both the batch layer and the speed layer. This serving layer uses the technologies like search engine or data visualization tools to enable the user to analyze the data effectively. Then, one more important feature of Lambda architecture is the immutable master copy. So, the Lambda architecture typically uses an immutable master copy of the entire data set. This means the data is never modified and new data could be appended to the existing data. So, this approach simplifies the data management and ensures data consistency across the layers. So, here one more component is present, that is query in the Lambda architecture. So, this query is nothing but it is responsible for submitting the end user queries to both the serving and the speed layer and consolidating the results. And that's all about the Lambda architecture. Next is the Kappa architecture. So it is an alternative to Lambda architecture for processing streaming data. The Kappa architecture is a data processing approach designed for real-time and batch processing using a single technology stack. It simplifies the architecture by focusing on a single processing path based on the stream processing technologies. Unlike Lambda architecture, which has a batch and a real-time layers, the Kappa architecture processes all the data as a continuous stream. So this is the architecture of the Kappa architecture. So here we have three components: Kafka cluster, stream processing system, serving database, and finally an app. So here, the Apache Kafka cluster acts as the store for the streaming data, and then the multiple stream processors can act on the data stored in Kafka to produce the multiple outputs. So in Kafka cluster, the input is present. In the stream processing system, the jobs are processed, and finally in serving database, the outputs will be stored. The apps can access the output in the form of the queries. So mainly these are the components of Kappa architecture. First one is data ingestion, next is stream processing engine, next is messaging engine, then serving layer, and finally analytics application. So we have five components in Kappa architecture. Let us see one by one. So first is the data ingestion. Data ingestion is nothing but data collection. So data enters the system from various sources like sensors, applications, or databases. So some of the example for data sources include event logs from web servers, IoT device sensors, database change logs, and finally transaction systems. Next comes the messaging engine component. So it is based on the stream processing architecture in which the incoming series of data is initially stored in the messaging engine like Apache Kafka. So this message engine acts as a buffer between the data source and the stream processing engine. It ensures scalability and fault tolerance. So next component is the stream processing engine component. So it is considered as the core or a heart of the Kappa architecture. So the stream processing engine ingests the continuous stream of data from the sources. It reads the incoming data stream and performs the data cleansing, transformation, aggregations, and finally transform the data into a suitable format for analysis. So example for the stream processing engine includes Apache Flink, Apache Spark Streaming, and Kafka Streams. The next component is serving layer, which is also called as the data store. So the processed data is stored in a distributed and scalable data store optimized for both real-time queries and analysis of historical data. So some of the common choices of data store includes NoSQL database, distributed file systems, then cloud object stores. So in NoSQL database we have HBase and Cassandra for real-time access. In distributed file systems, we have HDFS, Hadoop Distributed File System, for cost effective storage of large volumes. And in cloud object stores, we have Amazon S3 for durability and cost efficiency. So, next component is the analytics application component. So, here the applications can access the data in the store for real time analytics or batch analytics. So, the data analyst, dashboards, reporting tools, and machine learning models, all these interact with the serving layer to derive the insights and actions based on the processed data. Next comes the Kappa architecture use cases. So, Kappa architecture is used in many real time applications. So, first is the Uber, and then Netflix, and then Twitter. So Uber is a pioneer in adapting the Kappa architecture. In same way, Netflix, it is a leading streaming platform which uses the Kappa architecture to process and analyze the massive volume of event data it generates. Then Twitter, it also uses the Kappa architecture for real-time data analytics, data processing, then real-time trend detection, spam filtering, and much more. So these are the real-time use cases of Kappa architecture. So that's all about the concepts of stream processing and the architectures behind it. I hope this video covers a glimpse of information about stream processing. Thank you all. Thanks for watching.